Okay, so what we have here is the product that starts from 1 up to 30, and the question says determine the largest value of k such that 3 to the power of k is a factor of this product. So the whole point here is to find the multiples of 3 first that lie within the range of 1 up to 30. So you can write 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, right? So these are the multiples. So the whole point here is to identify bases of 3. So we don't care about anything else, but as long as we have a base of 3 such that we'll be able to find this value of k. For example, here 3 is just going to be 3, right? And it's to the power of 1, and this 6 multiplied 6 is equal to 2 multiplied by 3, right? So we don't care about these two, we only care about this 3 here. So just going to write 3, so it's going to be the power 1, and then to get 9 you can say 3 to the power of 2, right? And then to get 12, obviously there's multiples way to get 12, but you can just, for using 3, you can say 4 times 3, which we don't really care much about this, but this 3 here, so it's going to be 3 to the power of 1. And then for 15 it's 5 times 3, we don't care about the 5, but you take the 3 to the power of 1. And then for 18 you say 9 times 3 of 9 times 2, sorry, of which we don't care about this 2, so we care about this 9, of which this 9 you can write 3 to the power of 2. So we're going to write 3 to the power of 2. And then for the 21 we'll say 21 is equal to 7 times 3, right? So we don't care about this, we only care about this, so we write down 3. And then for 24 you can say 6 times, actually not 6, we can say 9, what am I doing, you can say 8 8 times 3, we don't care about this 8, we care about this 3, so just write 3. And then 27 is just 3 to the power of 3, and 30 it's 10 times 3, we don't care about this, we just take this, so it's 3 to the power of 1, right? So the whole point is to get bases that are actually 3, right? So that we'll be able to find the value of k. So now that we found this, we're going to say 3 to the power of k, right, is equals to, so just going to add the powers of all the bases here, all these bases, just going to add the powers, right? So if you add the powers, you're going to have 3 base 14 if you count all these powers here, all of them. If you count them all, you should get 14. And then you have the same bases here, so 3 to the power of k is equal to 3 to the power of 14, so therefore k value is equals to 14. So in this question we are told, or we are asked to determine the values of x and y if we have this expression here, right? So you have 3 to the power of y plus 1 over 32 is equals to the root of 96x. So the whole point here is to first simplify this, right? You know 32, you can write it as 2 to the power of 5, right? And you also know that 96, you can also write it as 32 times 3, which this 32 is actually equals to 2 to the power of 5 times 3. So let's first substitute these, right? So it's going to be it's going to be 3 to the power of y plus 1 all over 2 to the power of 5 is equals to the root of 2 to the power of 5 multiplied by 3. So obviously it's to the power of x, meaning that it's going to be x here and x there, right? And what you're going to do is just going to get rid of the square root, right? But before we do that, actually let's do that first. So we're going to have 3 to the power of y plus 1 all over 2 to the power of 5 is equals to 2 to the power of 5x over 2 multiplied by 3 to the power of x over 2. You know very well that a square root is like this, but can also be written as to the power of 1 over 2, right? So this 1 over 2 multiply everything that is inside, hence we have this expression here. So now that we have this, the whole point is to have one base on another side of an equation and the other base on like when I say the whole point is to have 3 to the power is equals to 3, whether it's to the power of x and 1 like that, it doesn't matter, as long as we have one base on one side and another base on the other side. We have 2x is equals to 2, right? One base on one side and another base on the other side. That's the whole point. We need to write it like that first for now. So what we have here is 3 to the power of 3 to, let me just write properly, so it's 3 to the power of y plus 1 right? Multiply by, I'm just going to take this up, so it's 2 to the power of minus 5 is equals to 2 to the power of 5x over 2 multiplied by 3 to the power of x over 2. So we have one base of 3 and another base of 3 here. So you can just equate them as they are. So you're going to have 3 to the power of y plus 1 is equals to 3 to the power of x over 2. Right, and also here we have one base here and another base here, so it's 2 to the power of minus 5 is equals to 2 to the power of 5 over 2x, right? Because the same base is just going to drop the exponent, so it's minus 5 is equals to 5 over 2x. Then you cross multiply, right? You have 5x is equals to minus 10 divided by 5 both sides, so x is equals to minus 2. So this is the first solution, and then you substitute it here. The x is equals to minus 2, so you have 3 to the power of y plus 1 is equals to 3 to the power of minus 2 over 2. You have 3 to the power of y plus 1 is equals to 3 to the power of minus 1. Drop the exponents. You have y plus 1 is equals to minus 1. Transpose this to the other side. You have y is equals to minus 2, right? So you're done solving this problem here. Okay, so what we have here is a question that says the roots of an equation are x is equals to minus n to plus or minus the root of n. So this is just the root closes here. So n squared minus 4 mp, where mn and p are positive real numbers. The numbers m, n, p in that order form a geometric sequence. Prove that x is a non-real number. So whenever you talk of a non-real number, it's basically the root gives you a negative, right? Or the discriminant is less than 0 is for non-real, right? Fine. So what you're going to do here first is to look at this second sentence saying that m, n, and p in that order form a geometric sequence, and a geometric sequence is defined by a common ratio, meaning if this is t1 and this is t2 and this is t3, therefore t3 over t2 is equal to t2 over t1, right? So r is equal to, what is our t2? T2 is n over m is equals to p over n. Cross multiply, you have n squared is equals to mp. So let's say this is our equation 1, right? And remember the second or the last part of the statement says that we should prove that x is a non-real. So non-real is discriminant less than 0, meaning that b squared minus 4ac is less than 0. So what is our b? Our b, actually just going to take what's inside here, inside the square root, because we don't have a standard form of equation. So just going to take what's inside the square root, which in this case it's n. Let me just remove this, which in this case we have what's inside the square root, it's n squared minus 4mp. It's less than 0. Then you transpose this to the other side, you have n squared is less than 4mp. Then you divide by 4 both sides, and squared over 4 is less than mp, right? So you can write it like this, or you can just let's leave it like this for now. If you check here, our equation 1, n squared is equals to mp. So you can simply say where there's mp, I can put n squared. So here we're just going to write n squared over 4, it's less than, so where there's mp, I'll put n squared like this, right? And you can just take the n squared to the other side. So you're gonna have n squared over 4 minus n squared, it's less than 0. You can multiply by 4, and all sides multiply by 4, multiply by 4, multiply by 4. You have n squared minus 4n squared less than 0. Then you subtract these because they are the same. It's like saying 1 minus 3 or 1 minus 4, right? It's the same thing. So here we're just gonna get an answer of minus 3n squared is less than 0. and then you can leave it like this if you want, because they didn't say find the solution of n, right? You can leave it like this if you want, or you can just divide out and have n squared being greater than 0, right? Because when you divide by -3, it's going to change the sign into being greater than. So it's up to you whether you leave it here or you leave it like this, right? So this is the solution, by the way. Or what you can do is the following. Instead of substituting, you see we had this equation here, and we also had this equation. Instead of substituting n squared, you can substitute mp here, right? So remember, n squared is equals to mp. So here I'm just going to put in mp. It's going to be mp over 4 less than mp, multiplied by 4, all sides you have mp, less than 4mp. Take the mp to the other side, you have mp minus 4mp less than 0. And then what you're going to do is you subtract both, you have minus 3mp less than 0. So you can leave it like this, right? Or you can just divide out the 3. It's just up to you. Yeah, then these are actually your solutions, this one here and this one here for this problem here. So you have proven that x is a non-real because you're getting a negative value here. Thank you. So here we are told that if n is the largest integer for which n to the power of 200 is less than 5 to the power of 300, determine the value of n. So the first thing we're going to do is just going to write n to the power of 200 is less than 5 to the power of 300. And we're just going to get rid of the power because we want to identify n. So we're just going to multiply by 1 over 200 multiplied by 1 over 200. And then n is less than 5 to the power of 300 over 200. Then the zeros go away. We have n is less than 5 to the power of 3 over 2. Punch that into your calculator and let me know what you're getting. So as I'm punching with you, I'm getting 11. So n is less than 11.1803. Right, so this is the final answer for this problem here. Okay, so this question says that calculate the maximum value of s if s is equals to s over x squared plus 2. So to find the maximum value of s is to, let's substitute x. Say x is equals to minus 1. What is the value of s? So it's going to be s is equals to 6 over minus 1 all squared plus 2, right, which is equals to 6 over 3, which is equals to 2. So therefore s is equals to 2, right? So this is the first one. And let's say, because if you're gonna say x is equals to minus 2, the denominator is going to be smaller, meaning s will be smaller too, right? So if it's 2, maybe it's going to be 1 or it's going to be 0. It's just going to be smaller. So it's pointless to continue on that one. So let's try out 0. So it's just going to be x being equals to 0. S is equals to 6 over 0 plus, so it's 0 squared, right, plus 2 is equals to 6 over 2 is equals to 3. So therefore s is equals to 3, right? And let's say you try x being equals to positive 1. So this is the same as this because there's a square root here. So irrespective of the sign, it's still going to give you the same answers, right? So therefore you can conclude and say the maximum value of s is equals to 3 at x is equals to 0. So this is your final answer. Okay, so what we have here in this question is we are told that we are given this standard form of equation, right, where m is not equals to 0. Determine the values of m. So here we're determining the values of m for which the roots of the equation are non-real. So whenever you say this, you know that discriminant is less than 0, right? So to determine the roots, we first need to write this down in standard form. So it's 2mx squared. We transpose everything to the other side. We have minus 3x plus 8 is equals to 0. Remember the discriminant, it's less than 0. So the discriminant, it's less than 0. Why? Because we're talking of non-real roots, right? And discriminant is b squared minus 4ac, it's less than 0, right? Of which my a is equals to 2m, this one here. My b is equals to minus 3 this one here, and then my c is equals to 8. So you're just going to substitute that into your formula. Instead of writing b squared, I'm just going to write my b, which is minus 3 all squared minus 4. My a value is 2m, and then my c value is 8. Remember the discriminant, it's less than 0, so it's less than 0 here. So 3 to the power 2 obviously is negative, but since it's squared, it's just going to give you 9 minus, and then 8 times 2 is 16, right? So it's minus 4 into 16m less than 0, and then 9 minus 16 times 4 is 64m less than 0, like this, right? And then you transpose the 60, so you're just gonna have 9 less than 64m, right? And then divide by 64, you have your 9 over 64 is less than m. So you can write it like this if you want, or you can simply transpose this 9 to the other side, where you have minus 64m, it's less than minus 9. Then you divide by minus 64, divide by minus 64. Remember, when you divide on an inequality sign, it changes. So it was less than, it's going to be greater than, so therefore m greater than 9 over 64. So this is the solution. Either write it this way or write it this way, it's still correct. So the question reads as follows: prove that the equation has rational roots for all rational values of p. So it doesn't say find the values of p, it just says that we must prove that it has rational roots for all rational values of p. That's the difference. I hope you guys can notice that. So please don't solve for p here. So the first thing you're going to do is just to deal with this standard of equation, obviously using a discriminant, right? And discriminant that is rational, we can just say discriminant equals to 0. Obviously it's rational, right? We know discriminant is b squared minus 4ac equals to 0, and our b is, obviously you need to sort this out because we have x and x here. So let's first sort out the standard formula. So what you're going to do is we have 6x squared plus 2px minus 3x minus p is equals to 0. To sort this out, we just need to factorize it. Take it out, so it's 6x squared plus x into 2p minus 3 minus p is equals to 0. Then we're done writing in the standard form, so we can now indicate that our b is equals to 2p minus 3, right? This one here, and then our c is equals to minus p, and our a is equals to 6, right? So just going to substitute that into our discriminant, right, which is b squared minus 4ac. So inside b squared, we're just going to write down our 2p minus 3 all squared, and minus 4 into my a, which is 6, my c, which is minus p, equals to 0. And then we have 2p minus 3 all squared minus, obviously it's going to be minus and minus, which is plus 24p, it's equals to 0. So let's sort this out here, which is 2p minus 3, 2p minus 3. So to multiply this product, we have 4p squared minus 6p plus 9. Right, so it's 4p squared minus 12p plus 9. So it's 4p squared minus 12p plus 9 plus 24p equals to 0. So to solve these two here, we have 4p squared plus 12p plus 9 equals to 0. And then we have to factorize this, right? So to factorize it, we're going to say, so it's equals to 0, so you're going to say 2p and 2p here, and then 3 there and 3 there, right? So that when you multiply this and this, it gives you 4p squared. When you multiply these 2p and this 3, it gives you 6, right? This and this also gives you 6, and this 3 and this 3 gives you 9. So it's plus and plus. So basically it's just 2p plus 3 all squared equals to 0. So I want you to notice this. It said we should prove that this equation has rational roots, right, for all rational values of p. So it does have rational roots because we're getting a squared, right? We're getting a squared. What does this tell you? It tells you that it's a perfect square. All right, it's a perfect square. So the discriminant is equal to perfect square. You can just say perfect square, right? So it is a perfect square, which means if we put it in a square root of 2p plus 3, you will get an answer of 2p plus 3, right? So it is a perfect square. Perfect square is rational, which means you can express it as a fraction. So in this question here, what we are given are two equations, this first equation and this second equation, right? And we are told that the equations have real and equal roots. So when they say they have real and equal roots, which means the discriminant is equal to 0, right? Solve for the values of r and m if r is greater than 0 and m is greater than 0. So let's first start with the first equation to solve it. So we know the discriminant it's equals to 0 and the equation is x squared plus rx plus m, right, of which the discriminant is b squared minus 4ac is equals to 0, and my a value is equals to 1 here, and then my b is equals to r, this one here, and then my c is equals to m. So it's going to substitute that with this b is just going to put r squared minus 4 into 1 and into m. It's equals to 0, so it's r squared minus 4m equals to 0. R squared is equals to 4m divided by 4. M is equals to r squared over 4. Say this is equation 1. And then the second equation now, right? I'm just going to do this. So the second equation, we have x squared plus mx plus r is equals to 0. We do the same thing. Discriminant, it's equals to 0. B squared minus 4ac is equals to 0, of which my a is equals to 1, b is equals to m, c is equals to r, right? So where there's b squared, I'm just going to put m squared minus 4 into my a is 1, my c is r equals to 0. So it's m squared minus 4 r is equals to 0. Remember, m is equals to r squared over 4. So where there's m, I'm just going to put r squared over 4, and then I square, so it's minus 4r equals to 0. So it's going to be r to the power of 4 all over 4 to the power of 2, which is 16, minus 4r equals to 0. We cross multiply, or we multiply rather the 16 throughout. 16 multiplied by 16, we have r to the power of 4 minus 64r is equals to 0, right? So to continue from this one here, so we have r to the power of 4 minus 64r is equals to 0. We just factor out the r, we remain with r to the power of 3 minus 64 equals to 0. So r is equals to 0, or r to the power of 3 is equals to 64. So just punch through the cube root of 64 into your calculator. You should get 4. So therefore r is equals to 4, right? So if r is equals to 4, you come back here, you substitute r. So it's going to be m, let me use a different color. M is equals to, where there's r I put 4, so it's squared over 4, of which 4 squared is 16, so 16 over 4 is just equals to 4. So therefore m is equals to 4. We're done with this question here. Thank you so much for watching. If you have any questions, suggestions or comments, please write them down in the comment section below. Otherwise, please subscribe to the channel and don't forget to click that bell button.